Nice to meet you, everyone. I hope everybody has a great weekend. Today we're going to talk about Terraform, the risk of using Terraform providers and modules. But before we go into that, I would like to introduce myself. Can you see my screen? Awesome. So my name is Uri. I'm the CTO and co-founder of ZEST. I have more than 10 years experience with vulnerability management and cloud security, specialized in both offensive and defensive security. As a former security architect, I faced many security challenges in my career. Some of them I would like to share with you today. So the agenda for today, we're going to talk about how we got here. I'm going to talk about barely on Terraform, how it works, in particular Terraform providers and modules. And the next thing I'm going to show you some analysis we perform on Terraform providers modules from a vulnerability perspective. The next thing, why we should take care of that. And after that, I'm going to show you two real scenario attacks of using one of them Terraform providers. The second one is the Terraform modules. And the last thing, and maybe the most important things, is the best practice and mitigation. How can you prevent this, or how can you reduce the risk? So let's rock. So as a security architect, usually my main goal is to make sure the company that I work for is completely secure, even though they use tools that I'm not aware of. So in this case, for example, when I have a tool that I'm not aware of, I go to the documentation and read the documentation, try to identify some security gaps there. So this is exactly what I did with Terraform. By the way, HashiCorp did a great job of document everything there. So everybody can read it. They document about everything, if it's the Terraform itself, providers, modules, so feel free to read it. What caught my eyes there was this section. The malicious Terraform providers or modules. Terraform configuration will have full access to the variable and Terraform state within a workspace. The second thing, Terraform cannot prevent the malicious providers and modules from exfiltrating this sensitive data. So now I had a question in my mind. What is Terraform providers and what is Terraform modules? And how attacker can use those malicious providers and modules to do some bad to my organization or the environment. So what is providers modules? So Terraform based on plugin, calls providers. They interact with cloud services, SaaS services, and also API targets. They define the resource type and also the data type for the resource that they're going to create it. Another interesting part is the attack surface for providers. Each provider is written in Go language, and also they communicate with Terraform core with RPC, and also with the target with HTTPS, which it make the attack surface very huge. And all of us know that each one of the components has so many vulnerabilities that we need to take care of that. In the other end, modules, they are a combination of TF file that help the user to organize the resource that you want to create. For example, if you want to create EC2 associated with some VPC, it's very convenient to developer or DevOps to use a TF file and with modules to create this together. The communication between the modules and providers, so the user will define what kind of resources you want to use based on the modules, and then a Terraform core will know to translate this message to the Terraform providers, and Terraform providers will interact with the API to create your resources. So for example, if you want to create an instance in your AWS, you will need to use AWS providers for Terraform. So now let's see how HashiCorp tag those providers and when they're stored those. HashiCorp has something called a registry, a Terraform registry, where they store all the modules and providers there. They have three different tiers. The first one is the official one. The official one is maintenance only by HashiCorp itself, and they're responsible for the security. The second one is the partner. The partner is other company that develop their own modules and providers, but they also part of the program with HashiCorp together. The last thing is the community. The community is individual contributor that develop their own modules and providers, or other teams that do the same for a community purpose. Another interesting part here is all the modules and providers for that HashiCorp has in the registry are accessible for everyone, which means attacker can use this to try to find vulnerability or to manipulate to create other malicious or providers or modules. So now we had several questions. How many vulnerability does repo has? So this is exactly what we did. We took the top 10 providers and modules for each one of the tiers, and then we scanned them with some static tool to understand if there are any vulnerability there, or the owners know how to fix that, or they are fixing it immediately. So what we found here, as you can see, so 60% of the critical AI vulnerability exists in the community. Partner has 29%, and the official one has 12%. The interesting part that I'm going to show you later is a vulnerable on the official one. So here you can see that the most highest risk number is in the community, but in reality, all of us know that all of them can have the same risk here. So now I have a question for you guys. But before the question, does having more non-vulnerability make you more or less secure? In my opinion, it's a tricky question, because if someone has a lot of vulnerability or CV, maybe he scan a lot. He try to identify the security. And this is the reason he has a lot. But I do have another question for you. How many of you use Terraform in production system? Feel free to raise that. Awesome. How many of you know which of Terraform providers or module you are using? All right. And the last question, are you guys scanning those providers for vulnerabilities? All right, I see one end. All right, so our next question was, how many user downloads those providers and modules? So as you can see here, we're talking about millions. This is an insane number, because this is only the community. If we're talking about partner and official, the number is much higher. So this is, again, highlighting why we need to take care of the risk of Terraform providers or modules, and also how we need to handle those. So we cover the risk analysis. We cover a bit how providers and modules communicate together and what are they. So why it's important? So first one, it's attractive. As we see, we're talking about millions of downloads only for the last month. The second part is a measure blind spot. I asked you a few seconds ago, and almost I didn't say. I see only one end that is scanning those for vulnerability. We need to make it sure that it's part of our application security program. The last thing is, of course, I think everybody knows, it's manual and expensive remediation. It's very difficult to fix things, and it takes a lot of time. Now let's talk about the two attack scenario, the juicy part. The first one, I'm going to talk about exploiting non-vulnerable for one of the providers. The second one is the malicious Terraform modules. Let's start with the first one. This is a CV from 2021. I faced this CV 3 years ago, and so it's a real story. This has happened in my organization. So the vulnerability itself related to Vault Provider. Vault Provider, remember the tiers that I mentioned before? It's one of the official one that we assume it's a secure one. So the vulnerability itself, if you will define a role, authentication vault with, and also define a role there, you need also to define some bound labels and bound services to restrict the access to other service account for GCP. The problem is the provider map it incorrectly, which means everybody can authenticate that. So once the attacker will identify that you're using this vulnerable provider, you can easily bypass a privileges escalation with only read the access permission. So let's see how it looks in real time. So the first thing the attacker needs to obtain a read-only access. Once he did that, he needs to identify that the user or the organization use Vault, and also they define they configure Vault with Terraform. As you see here in the top, the piece of code, it looks very like it's the best practice. They define it well. There is bound services, the bound label, and everything. It looks as expected. However, when we execute a Terraform apply, what will happen that the communication between Terraform modules to the providers, there is an issue with the mapping there. So this is the problem on the provider itself. So instead of bound label admin role, it will put bound label empty. This is the reason everybody can authenticate that. Once the attacker identified the vulnerability, the only thing you need to do is to authenticate with Vault. So you can write the command in the bottom, if you can see it. All right. The Vault write authentication with a role admin to privilege escalation, and surprisingly, it will bypass the authentication. Right now, the only thing it needs to do to take control of the environment is to run authentication with a Google API. At that moment, we are screwed. Why? Because now we can do it can do whatever it wants in our environment. It can do a lateral movement, data exfiltration, or service disruption. And again, this is happened to me and in my career. So this is why I think it's very important to show it to you guys, to understand that don't take as expected your providers and modules. So now let's talk about something else. Sometimes you don't need to work hard to exploit a vulnerability in the provider. Sometimes the provider itself exposes some sensitive information in your Terraform state file or even in your logs. In this example, this is interesting, by the way. You see three Terraform providers. The first one is part of Microsoft. It's the only one that has a CV. The others, they have an open issue in the repository. If you go to the GitHub repository, for example, to console, you see the issue there, but there is no CV related, which means sometimes we will going to miss the CV itself. This is emphasized the reason that we need to go to the repo and to read the comments, to read the issue they have, to identify security that we are not aware of. So both console and Akamai have some exposed sensitive information, and none of them has the CV, at least yet. And by the way, console still closed the issue without CV. So we talk about malicious providers, about vulnerable providers, and how attacker can leverage this to get access to your cloud environment. Now let's talk about modules. Modules can be malicious. So an attacker can create or clone known modules from GitHub and convince a victim to download it and to use it. The option of installation from modules is large. The most common are Terraform registry and GitHub and HTTPS. But as you can see here, there is a bunch of other options, which mean the attacker has so many options to try to manipulate the user, to download it, and to get into the environment. What I'm going to show you in a few, it's a Terraform module that creates an EC2 instance. It will look a legit module, but other than that, it will inject a backdoor together by using user data. Let's see how it looks like. So the first thing, the attacker needs to publish a malicious module. You need to upload it to GitHub or even though to Terraform registry. It's very easy to do that. You can read the documentation and see how it works. Once he did that, he needs to convince the victim to download the modules. Once the victim downloads the modules, he needs to import it to his TF file, as you can see here below. Even though it's a malicious, you're not going to say a malicious module. So right now, the provider, the victim use AWS provider. He also use module called EC2 instance, import it for a directory called for a malicious modules, and then he define the EC2 instance that you want to create. Now the only thing he needs to do is to run Terraform plan to see that you're gonna what Terraform gonna plan to execute, and the next thing you're gonna do Terraform apply. Once you do a Terraform apply, Terraform will create the EC2 instance. But other than that, you will also establish a backdoor to the attacker. Let's see how the malicious module looks like. So as you can see, it looks legit. So the module itself using the AWS provider, create the AWS instance. You define the AMI, you define the instance type, everything looks good. But other than that, there is a user data there, encoded in base 64. Even though security team will suspicious about that, but I saw many times DevOps use it just to make the user data much more short. So if you're going to decrypt it, you're going to see the backdoor that the attacker will inject. The output in the final, it's just to provide the instance ID for the victim of the instance itself. You see how simple is it to create a malicious modules? This is only one example. There are several examples, and there is nothing bad happening here. They are just using the malicious. They are just using the API for AWS to manipulate the user to do something bad for their environment. Now let's talk about the takeaway. So we cover two scenario of attack. Two of attack scenario. There is more. There is also malicious providers, of course. We talk about some analysis that we perform on the provider's modules itself. Now let's talk about what we can do to prevent it or to reduce the risk. Sorry. So the first thing is due diligence. Read the documentation. Try to identify some security group the provider has or the modules. Read the source code. Try to identify if there is any injection or a potential of injection, or if the provider itself executes some command line. Read the feedback from the community. It will say a lot what the others think about it. Keep scanning the repository and the code for vulnerabilities. Even though it's very difficult to exploit the vulnerability in provider, it will say a lot what the owner or the creator think about vulnerabilities. Pin the version of your provider to reduce vulnerabilities. Enable the state file locking to prevent attacker to manipulate your state file. If we will manage to do that, it can destroy your environment. Put your Terraform lock HCL under version control. This will help you to monitor what kind of Terraform provider version you're using. Keep audit your Terraform plan and state file for misconfiguration and unexpected changes. The last thing, I'm sure you're doing that, scanning your IEC with the IEC security tool to identify misconfiguration. But remember also to scan the provider itself with some static tool just to be aware if they have a vulnerability there. Now let's talk about mitigation. Sometimes you cannot fix things. Sometimes you can implement some control to reduce this risk. So this is four mitigation that I can offer for you, but there are several more. So the first one is use IAM role and policy to restrict access to your CI/CD system and application log, especially for the TF state file. Use IAM role for Terraform. Use only temporary credential and not the long-lived secret. Networks restriction. Use VPC, load balancer, and WAF to enable non-communication between services. Many times I saw developers, DevOps allow inbound and outbound for IP 0000. If you can prevent it and implement your control there. Use CWPP and SAS prevention to detect malicious communication. use CloudWatch or or rules system to detect if someone tried to attempt your state file for or read it or to write it. I hope it was insightful for you, and I hope you will take it more seriously now, the provider itself from Terraform. Any question? All right. Thank you, Phil.